Humanity spent $10 billion and 25 years building a machine for one photograph. The universe's baby picture, the first few 100 million years after everything began. We knew what a baby universe should look like: small, shapeless, barely lit. The picture came back in the summer of 2022, and there was no baby in it. There were finished galaxies, there were dead ones, there were graves in the maternity ward. The picture was not wrong. Our idea of the beginning was. And to see why, you have to start with what that machine is really doing when it looks. Because in space, looking far means looking back. The faint light hitting your eye on any clear night set out before you existed, before your city existed, and for some of those stars, before your species had even stood upright. The sky is not a view. It is an archive, and the farther into it you look, the deeper into the past you fall. The universe is expanding, and we've known that for nearly 100 years. As space itself grows, it stretches the light traveling through it. A wave of light that spends billions of years on the road gets pulled longer and longer, shifts toward red, and finally stretches past what your eye can see into the infrared. Light from the universe's earliest ages is invisible by the time it reaches us. So an eye built to watch the universe's infancy had to see in infrared. And to hear that faint signal, it had to be stripped of even its own warmth. Webb was built for exactly this. It was carried 1.5 million kilometers from Earth, hidden behind a giant shield, cooled to minus 230 degrees, and turned toward the dark. It had a single task: to look into the universe's first few 100 million years, into the dark room where everything began. And keep this in mind: nothing this machine sees still exists as it sees it. Every scrap of light it catches is the last letter of something long since changed, perhaps long since gone. Webb isn't really a telescope. It's an excavator, digging where the past lies buried. And as it dug, unexpected things began to come out of the grave. What we expected the dig to turn up was clear. The scene the model had described for decades went like this. In the beginning, there would be shapeless, feeble clumps of newly igniting stars. The universe builds everything from small to large, bricks first, the city last. Small clumps would collide and merge, and over billions of years assemble today's great galaxies. Nobody was expecting a surprise. What everyone expected from the telescope was a confirmation, a signature on the model's final page. We were going to take the universe's baby picture, and in that picture, we would see a baby. The picture came back, and there was no baby in it. In the very first deep images, in the earliest months of 2022, bright, mature-looking galaxies stood fully formed and settled in an era when the universe should have been crawling. The math didn't work. There was no known way to gather that much mass that early. Some researchers nicknamed these first objects universe breakers. The internet caught fire. Headlines declared cosmology broken. Videos circulated saying the model was bankrupt. The headlines treated it as the end of the affair. It was the beginning. The shovel had barely broken the surface, and as the digging went deeper, what came up made that first shock look gentle. Because in the months that followed, records began to fall one after another, and every new record was stranger than the last. One of them, a galaxy catalogued as JADES-GS-Z14-0, had sent us its light from roughly 290 million years after the Big Bang. To feel what that number means, consider this. At that moment, the universe was at 2% of its current age. In an 80-year human life, that's a baby of 1.5. And inside that baby blazed a structure 1,600 light years across, birthing stars at a furious pace. Then it got darker. In 2025, 2 separate teams dissected that galaxy's light with a giant array of antennas in Chile and found oxygen in it. On its own, oxygen sounds like a minor detail in a paper. It is anything but, because oxygen is the ash of stars. The universe began with nothing but hydrogen and helium. Heavy elements like oxygen are cooked only inside stars, and they only scatter when those stars die and explode. So if that galaxy held oxygen, whole generations of stars had already lived and died there. We looked at the universe's baby picture, and inside it we found a cemetery. The cemetery was only the first thing the dig turned up, because the next find was, quite literally, a corpse. The galaxy cataloged as RUBIES-UDS-QG-Z7 looks at us from just 700 million years after the Big Bang, and by that moment, it was already dead. Here's what I mean by dead. A galaxy dies when it stops giving birth to stars, its growth halts, its young blue stars burn out, and all that remains are aging red ones. This galaxy had packed more than 10 billion suns worth of stars into a tiny region 650 light-years wide, and then shut down production entirely before the universe turned 700 million years old. There isn't a trace of a single young star in its light, only the old. Our models didn't allow for such a thing existing that early. By the math, objects like this should be at least 100 times rarer than what we found. And nobody knows where this thing is today, because the image we see is 13 billion years old. That dead giant has either dissolved into other galaxies by now, or it's still out there as the buried core of some massive elliptical galaxy, maybe lying at the very heart of one of the galaxies you'll look at tonight. We walked into a newborn universe, into the maternity ward, and inside, we found a retirement home. As if the retirement home weren't enough, that young era also produced a perfect machine. A galaxy announced in 2025 and nicknamed the Big Wheel sent its light when the universe was only 2 billion years old. 2 billion years sounds long, but understand, that's still before the universe's first quarter, its most chaotic youth. And in the image from that era sits a spiral disk more than 100,000 light-years wide, carrying about 5 times the Milky Way's mass in stars, turning calmly on its well-formed arms. Like our galaxy, but bigger, and more than 11 billion years earlier. The problem here isn't even the mass, it's the order. A spiral disk turns like the gears of a wheel, and building that kind of order takes time, takes billions of years of quiet maturing. In the loudest, most collision-filled era of the universe, a structure like this shouldn't have survived. One of the researchers on the team compared the discovery to running into a living dinosaur before extinction. And this galaxy wasn't even being looked for. It was waiting by chance at the edge of an image opened to study something else. In a frame nobody was watching, a giant that shouldn't exist. And the giants are only half of what the excavation brought up. Because however early and however large the galaxies are, at least we know what they're made of. Gas and stars. The real breakdown in the order of things showed up in what sits at a galaxy's heart, in the black holes themselves. Listen to how a black hole grows, the way the model tells it, because in a moment this account is going to crack in front of your eyes. a great star dies, collapses onto itself, and leaves behind a small black hole of a few dozen solar masses. That little pit grows by slowly swallowing the gas around it. But there's a speed limit to the swallowing, and that limit is the cruelest part. The faster a black hole feeds, the hotter the matter pouring into it becomes, and the more fiercely it shines. That light pushes outward and shoves the black hole's food away. The greedier the black hole, the faster it flips its own table. Picture a creature strangling itself with its own hand. That limit is called the Eddington limit, which is why climbing from a small seed to millions of solar masses should take hundreds of millions, even billions of years. And time was the one thing the early universe did not have. And exactly where there was no time, the telescope began finding monsters that needed it. At the center of a galaxy cataloged as CEERS1019, just 570 million years after the Big Bang, sat a black hole of 9 million solar masses. For comparison, the black hole at the center of our own galaxy weighs 4.5 million suns. Something twice the weight of the monster at the Milky Way's heart was already in place in the universe's first breath. And it wasn't idle. By the measurements, it was feeding at the fastest rate its size allowed, pressed right up against that merciless limit, as if it had arrived late to the table. The team that discovered it wrote plainly that this mass is hard to grow from the seed of a dead star. The words are polite, the meaning is not. The meaning is, we don't know what this thing is doing there. The heaviest form of we don't know lay buried deeper still, and even the way we dug it out is unsettling in itself. In the sky, 3.5 billion light years away, there's a giant cluster of galaxies called Abell 2744. It's so heavy that its mass bends the light passing behind it, acting like an enormous magnifying glass. The universe, with its own hand, holds up a lens so we can see into its depths. And through that lens, from far, far behind the cluster, a faint ghost appeared, magnified 4 times, cataloged as UHZ1. Its light had been traveling for more than 13 billion years. The moment we see is just 470 million years after the Big Bang. Webb saw the galaxy. But the real blow came from Chandra, the telescope that listens for X-rays. From the center of that faint ghost came the scream of a feeding black hole. The calculated mass, around 40 million suns, at a time when the universe hadn't seen its 500 millionth birthday. 40 million suns is a terrifying number on its own, but the true horror of this object isn't its mass. It's the ratio. In our corner of the universe, a strict rule holds. The black hole at a galaxy's center weighs roughly 1,000th of all its stars combined. The house is huge. The pit in the basement is small. In UHZ1, the ratio isn't 1 in 1,000. By the measurements, the black hole's mass is close to the total mass of all the stars in its galaxy, nearly 1-to-1. That is not a black hole that grew inside a galaxy. That is a black hole with a galaxy clinging to its edges as an afterthought. As if the pit had been dug first and the house placed beside it later, the order running backward. And that backward order dragged an idea back onto the table that nobody had ever proposed as a joke. The idea is this, and I'm telling you plainly that it is not yet a proven fact, but a strengthening hypothesis. Maybe some black holes were never stars at all. Maybe some of the giant, pristine gas clouds of the early universe, instead of breaking apart into stars and shining, collapse directly onto themselves in one piece. This is called direct collapse. From a collapse like that, a black hole is born already carrying tens of thousands, maybe hundreds of thousands of solar masses on its first day. Not a small seed, but a heavy one. A giant from birth. Every measured property of UHZ1 fits the theoretical predictions made years ago for exactly this kind of object. If that's true, then in some corners of the universe, darkness organized before light. Stars weren't the first arrivals everywhere. Some galaxies came after the abyss at their center. First the abyss, then the house. Write that backward sentence in a corner of your mind and look at the whole picture at once, because the whole is darker than its parts. On one side, galaxies many times too mature for their age, and giants dead on arrival. On the other, black holes that seem to have come before their galaxies, and those are the most disturbing of all. Each of these comes from a different team, a different observation, yet they all speak the same sentence. Something in the early universe grew much faster and much darker than we understand. The light of that era is still on its way, still arriving, still pouring over your head every night. The problem is not solved. The problem is hanging in the sky right now. And in those same frames, amid all the noise of the giants, the strangest thing the excavation turned up was nearly thrown out with the rubble. Because while scientists argued over huge galaxies and premature black holes, something else was hiding in the corners of the very same images. Something no one took seriously. Tiny, deep red dots. They were so small and so faint that at first glance, they were dismissed as image artifacts or meaningless smudges. Then they appeared in another deep image, then another. Wherever the telescope looked into the universe's depths, a few of those dots stared back out of the dark. Their numbers were counted first in tens, then in hundreds. They all shared one property too, and it was the strangest of all. They all belonged to the same narrow era. At a certain period of the universe, they step onto the stage together, glow a smoldering red for a while, and then vanish from the record together. An entire population, appearing at once and disappearing at once. We knew of no kind of object that did this. For years, nobody could say what they were. Some said galaxies. The math failed. Some said star clusters. The light didn't fit. Then, the universe repeated the favor it had done at the Abel cluster. One of those red dots happened to sit directly behind a massive cluster of galaxies. And the cluster's mass magnified and brightened that tiny light. The researchers didn't waste the gift. They took that single dot's light apart line by line and demanded it spill everything it held. And it spilled. What came out was not a galaxy. It was not a star either. What came out were the signatures of a third thing, something in between, something we had never seen before. The oldest era of the sky, it turns out, had been full of them all along, and we have only just begun to look. Before I tell you what that third thing is, you need to know how these dots first became our problem, because the most embarrassing part of this affair is that the answer had been sitting in our hands from the start. The year is 2022. Webb has had its eyes open for barely a few weeks, and already, in those very first frames, the tiny crimson specks are there, scattered across the sky. Nobody turns to look, because everyone's eyes are on the giant galaxies and the falling records. The specks are dim and boring, but every time the telescope dives deep, it pulls up another handful. In the words of one researcher, this is a huge mystery, sitting inside every single image we take. Wherever humanity's most expensive eye turns, the same unidentified thing appears in a corner of the frame, as if that era of the universe were carpeted with them, and for years we had been wiping the smudge off the edge of the photograph to look at the main subject. By 2025, more than 340 of them have piled up in the catalog. And there's a fact nobody can ignore anymore. These things are everywhere. In the corner of nearly every deep image Webb takes, one of them lies in ambush, glowing red out of the dark. They are everywhere, but they are not everyone. And this is the part that settles in your gut. This population has a calendar. Around 600 million years after the Big Bang, they all step onto the stage together, and before the universe turns 2 billion years old, they all vanish from the record together. Before that, nothing. And after that, nothing. An entire kind of thing that belongs to one specific era of the universe, born with it and gone with it. Like every window in a city lighting up on the same night and going dark together some nights later. Nobody knew who turned the lights on. Nobody knew who turned them off. The not knowing didn't last, because the first guess came fast. And it was the most frightening one. These dots were so bright that when you converted their brightness into stars, the result was absurd. Giants of billions of stars crammed into a tiny space at the most extreme density possible. In other words, the very universe breakers problem I described in part 1 in its heaviest form. That much mass could not exist that early. The model forbade it. These dots were, in large part, the real fuel behind the headlines declaring cosmology dead. The numbers were on the table, the math was on the table, and the math was at war with the universe's official history. But inside that math, an awkward detail sat grinning, one nobody wanted to face for a long time. If these dots really were galaxies packed with stars, the crowding inside them had to be beyond belief. One research team took that seriously and tested it, and the result was almost comical. In a system that dense, stars would collide roughly once a month. In our galaxy, a collision between two stars practically never happens. There, a catastrophe would erupt every month, and those collisions would heat the gas to millions of degrees and drown the region in X-rays. So, were X-rays coming from those dots? No, not even a whisper. And that silence changed the fate of the entire investigation. Because an actively feeding black hole normally blasts out X-rays too, and so does a crowded nest of stars. These things were shining, but they were silent. There was something in the sky, radiating light and invisible on the X-ray, and nothing in our inventory matched that description. The answer began arriving in early 2025, when two separate teams took apart the light of two separate red dots, line by line. In the spectrum of one of them, there was a sharp step, a place where the light dropped off as if over the edge of a cliff. And that is why the researchers named the object the cliff. A step like that is normally the signature of old stars, of a population billions of years old. But this signature was forged. Up close, the step was drawn not by old stars, but by an unbelievably dense curtain of gas pulled in front of the light. The light left its source, but before it could reach the outside, it had to seep through a thick shroud. And light passing through that shroud came out dressed as something else entirely. What we had spent years calling old galaxies was something else in disguise. The hypothesis that finally named that something goes like this, and I'm saying up front that it is still a hypothesis. not a proven fact. The black hole star? Picture it. At the center sits a newborn, hungry black hole. Around it wraps a giant envelope of gas, 100 billion times denser than the space between stars. As the black hole feeds, it pours out savage radiation, but that radiation can't get out. It's trapped inside the envelope, roasting it from within, and the roasted envelope leaks a deep, muffled red glow outward at roughly the surface temperature of a star. Someone looking from outside sees a star, but it is not a star. There's no fusion inside, and the light is made not by burning hydrogen, but by a feeding abyss. A black hole buried in the body of a star. The X-ray silence solves itself too, because the envelope swallows those hardest rays, and only the red glow escapes. That is also why the dots are so red. That color isn't the calm light of a galaxy. It's a smothered scream leaking from under a heavy shroud. Think of a furnace burning in a closed room, and the red line seeping under the door. You don't see what's inside the room, you only see the leak. What Webb had been photographing for years was that leak under the door. And behind the door waited the hungriest thing in the universe. The most insidious detail in this picture is what the envelope does for the hungry thing at its center. In part 1, I told you about the black hole's cruel speed limit, how the faster it feeds, the harder its light pushes its own food away, flipping its own table. That rule applies to open tables, where the food can escape. Here, the table is sealed. The envelope is so heavy and so tight that the light pressing from inside cannot tear it away. Instead, the envelope's own weight shoves matter down the black hole's throat. Force feeding, in other words, a meal that cannot escape and a mouth that is never allowed to be full. In a setup like that, a black hole can grow above the famous limit, with a gluttony the model normally forbids. Remember the question we asked in part 1. How could black holes this big exist this early, when they had no time? Here is a way to grow that needs no time, and the idea isn't even new. 20 years ago, in 2006, a group of theorists calculated that exactly such objects could exist, and they called them quasi-stars. A prophecy nobody had ever seen, waiting on paper. The crimson specks in Webb's photographs matched the description of a prophecy written 20 years earlier. The hypothesis was beautiful, but science does not settle for beauty, and the next blow came from the calculator. A study published in early 2026 went through the red dots with the highest quality spectra, one by one, and showed this. The frightening width of their light lines did not come, as we thought, from gas flung around by enormous masses. The light was fighting its way out through the electrons in that dense envelope, scattering off them again and again, smearing a little more with every collision. Like a street lamp in fog, the lamp looks far larger and blurrier than it is, but it isn't the lamp that grew. It's the fog in between. When the fog was subtracted from the masses collapsed in front of our eyes by a factor of 100. The universe-breaking giants shrank into young, small black holes between 100,000 and 10 million solar masses. And those masses were no longer a weight the model couldn't carry. Cosmology had not broken. We had looked at fog and seen a monster. But note this, the correction did not exactly put anyone at ease. Because as the mass shrank, another question grew. If there was no giant of billions of stars in there, what was making these tiny things shine like whole galaxies? A fog that makes an object look 100 times bigger than it is. What was it hiding behind it? So was it all an illusion? No, there really was something behind the fog, and that something turned out to be more interesting than the monster. The closest we've come to hard proof arrived in mid-2026, when the universe held out its lens once more. Directly behind a giant galaxy cluster called Abel S 1063, a red dot was hiding, and the cluster's gravity was magnifying its light. The researchers locked Webb onto it. Roughly 30 hours of observation, boosted by the lens, turned into the equivalent of 80 hours of data, and out came the deepest spectrum ever taken of a red dot. More than 40 separate lines spilled out of it, lines of hydrogen and helium, and a pattern woven from 16 separate iron lines, which the researchers call an iron forest. Every one of those lines was a separate witness, and every independent witness gave the same testimony. This light is not coming from a calmly rotating cloud of gas. This light is seeping out through a dense, layered shroud off the back of a feeding black hole. It is still not a closed case. We don't know how the envelope forms or how it survives. But the deepest data we have today points at the strangest hypothesis. Accept that hypothesis for a moment and look again at the 3 riddles that have been piling up since part 1, because this single idea strings all 3 onto the same thread. The riddle of the 2 mature galaxies. Part of that early brightness was never starlight at all. It was black hole light in disguise, and the masses looked inflated. The riddle of the black holes in the wrong order. If black holes spend their youth in sealed envelopes like these, force-fed, then outgrowing their galaxies stops being a miracle and becomes a mechanism for pits heavier than their houses, like UHZ-1. That leaves the riddle of the red dot's calendar, and that synchronized disappearance was not the death of a generation. It was a generation undressing. An envelope cannot last forever. The black hole either devours it or blows it away. When the shroud lifts, the red glow dies. What remains is a naked, silent black hole, and the dot vanishes from the record. And indeed, in the early universe, stark, naked black holes have been found with almost no stars around them. Maybe they are old red dots that finished consuming their covers long ago, so the dots did not cease to exist. They merely became invisible. And that is the most unsettling way to disappear. A thing that dies leaves behind a corpse or a ruin. These left no trace. They switched their lights off and blended into the dark, and the universe went on being full of them, whether we could see them or not. Inside the black emptiness staring back at you tonight, nobody knows how many of them are sitting silently, their shrouds long since eaten. Nobody knows, but here is what we do know now. The headline sold this as Cosmology collapsing. The truth came out better. Better in every direction. The model didn't break, but something nobody ordered was set down on the table. An entirely new kind of object. And quite possibly the unknown infancy of supermassive black holes. At the heart of nearly every large galaxy today sits a giant of millions or even billions of solar masses, and how they were born has been one of astronomy's oldest wounds. Now, we have a candidate. Those giants did not grow up naked in the open sky. They grew behind closed doors, force-fed, and thanks to Webb, we may be standing in front of those closed doors right now, watching the light leak out from inside. We are watching the nursery of a species, and that species is the darkest thing in the universe. And this is no longer the curiosity of a distant era, because one of that nursery's graduates is waiting very close to you. At the exact center of our galaxy, the Milky Way, sits a black hole of 4.5 million solar masses. Pay attention to that number. The corrected masses of the red dots range from 100,000 to 10 million suns, and ours falls squarely inside that range. It is not proven, but the possibility is now on the table. Maybe our own giant fattened in its youth inside one of those crimson envelopes, glowing low and muffled. Maybe the Milky Way was woven around a surviving member of that lost population. Tonight, if you step outside and look toward the constellation Sagittarius, in that direction, 26,000 light years away, that dark thing sits, quiet and patient. And if this picture is right, then you and the planet you're standing on live in the outermost neighborhood of a crowd arranged around something that was once force-fed in the dark. The house came after the pit, and you came with the house. It was Webb that handed us this picture of the house coming after the pit, and give it its due. The telescope did not inflate a crisis here. It more or less resolved one, because it deepened the very measurements that started the panic and showed, piece by piece, where the mistake lived. The fog cleared, the model stood, and on top of it all, we gained a new object. You can't help thinking, so if this telescope just looks deep enough, every crack closes like this. If only that were true. Because the same telescope reached for another measurement, the most basic number we have about the universe, how fast it is growing right now. We measure that number in two separate ways. The two ways give two different answers. For years, everyone hoped the gap was nothing but a measurement error, and Webb turned its sharp eye exactly there. It looked for the error, and it did not find one. Instead, it eliminated the possible errors one at a time, and with each one, another place where a mistake could hide ceased to exist. The gap stayed exactly where it was. I won't name that possibility here. That is another file. For now, know this much. With the red dots, we were the ones who were wrong, and our mistake handed us a new object as a gift. In the next crack, the ones who are wrong may not be us, and there is no gift under that possibility.